Good afternoon. Welcome to this talk. You would never say that modern DevOps and C and C++ would be in the same slide, but today it's going to be. My name is Diego. I'm one of the Conan C and C++ package manager co-founders, together with Luis. And now we are going to see what can we do for DevOps for C and C++ projects. So this would be like the typical flow. We want our C and C++ developers to do source changes. We want those changes to go as quickly as possible to production, or at least to be used by other developers. So we want this flow to be as fast as possible. So how does a continuous integration flow works for C and C++? So we can have a Jenkins there, and we can have a main CPP application. So Jenkins can fire any build system like CMake or Visual Studio, Makefiles, whatever. That in turn will use the compiler we want to use, Visual Studio in Windows, GCC in Linux, Apple Clang in OS X, for example. And we will end with a final application. And that final application, Jenkins can put it in Artifactory or upload elsewhere. Okay? The thing is that for C and C++, it is not that easy. One important thing, one challenge, is that C and C++ projects are also huge. Typical size would be like tens of millions of lines of code of C and C++ code. And also, we have a problem, is C and C++, because of the headers and the preprocessor, compiling times are huge. So there are tricks, there are precompiled headers and things like that, but builds are generally slow. So you cannot trust of building from sources in your continuous integration all the time. And you need to develop some kind of dependency management that, of course, will have to have transitive dependencies. For example, my main CPP file in the previous slide is dependent on a library, my own library. And that library, in turn, is using the POCO C++ libraries. It's a famous framework to do some stuff. And in turn, POCO will be using OpenSSL, and OpenSSL uses setlib. And every time I'm building my main CPP, I cannot be building from sources all of them. So it is obvious that I have to manage those dependencies, POCO, OpenSSL, and setlib, as binaries. And I have to use it as binaries. And not only that, but I have to be very careful with the compatibility, because in C and C++ we have the thing that is called the AB compatibility. So a binary that you build with Visual Studio 14 might not be ABI compatible with another version of the same compiler. Or even if you change your settings and you're doing a debug build, that debug artifact, that binary, will not link properly with a release artifact. So we have a problem there, and our tools have to manage this. They have to be careful and use the correct binary you have to use. So for that, a package manager is an excellent tool. It's something that you have to do. Every company, and I guess that you're here because of some reason, is developing their own tools. So you can use Conan, or you are developing yourself something to do this. So in this case, Conan, what it is an open source package manager. It is MIT, so very permissive license to do whatever you want with it. It is portable. It will run in any machine that can run Python. So it is very tested and used in Windows, Linux, Macs, also FreeBSD and Solaris, for example. It is decentralized, so you can use, it's exactly like Git. So you can have any remotes, and you can push and pull artifacts from one to the other. It manages binaries, so it is able to build from sources, but it also manages your binaries. And it will take care that the binaries that you are using when you install your dependencies are compatible with your current settings and the settings you are using for building. It is based on Python scripts, so the same as Homebrew, for example, if you use it, is using Ruby for the formula. We are using Python scripts to define the packages. And it is not attached to any build system. So we use CMake a lot in the examples and in the documentation, but it can actually work with any build system. It works pretty well with Visual Studio, without the tools. So let's see how can this help in a continuous integration flow. So let's suppose that we have a developer that has fixed this very obvious bug in this very obvious source code. It's C++ code. Who is hating right now their C++ developers? Actually, C++, I'm throwing you, and C++ is not only the most powerful language in terms of performance with C, of course, but it's also a great language. It has true generics, it is expressive, and is one of the most loved, especially C++ from C++ 11, is one of the most loved languages out there by programmers. So now we have a change in our source code, okay? And that source code, we are building like a library, a certain library, that already has some dependencies, like Poco, OpenSSL, or even our own dependencies. But we want just to build our library, because the others are pre-built. So the first step that a Jenkins job would do is, okay, so I'm going to retrieve my library dependencies, the binaries, I will retrieve from somewhere, for example, from Artifactory. And with those binaries, it will create like the dependency graph of the dependencies for my library, and it will inject that information of your dependencies into the build system of my library. Then it can take the source code, use any build system, like CMake or whatever, and create the final binary artifact. Like in this case, my library, it could be a static library or it could be a dynamic sort library. And finally, those changes, that binary, we want to close the cycle and upload to Artifactory. So other developers or someone is releasing the final application will use just the latest artifact, the latest my library artifact that we have just created in continuous integration. Of course, all of this, as I told you, is multi-platform. So the storage model for Conan is that you have a package recipe, and for that package recipe and source code, you can have any number of binaries and any different configuration. For example, if you are using Visual Studio, a certain version, or you are using GCC, you will get a different binary. And all of those binaries are attached to and managed together with the recipe. And in the storage, let's say in Artifactory, you have all of them, and you can navigate, you can search for binaries, and so on. But when you are developing your developers, or when you are creating like a final release in a certain system, it will be very efficient, because if in the developer machine, in this case, for example, is working in Windows with Visual Studio 14, it will retrieve first the recipe, it will check the settings, the current configuration, and it will only pull the artifacts you need. So one of the problems with C and C++, for example, you take a big library like Boost or OpenCV, and if you want to install OpenCV, like the tarball is like 1.5 gigabytes, because it is packing together all the debug release artifacts for all the Visual Studio version. So it's 1.5 gigabytes only for Windows. In the Conan is just getting the only artifacts you need. So it's very efficient to have like a very fast flows in continuous integration, or by developers. And also the opposite. If you are doing some changes in your source code, you can just push them to control version. Jenkins can fire several jobs in parallel, and it can build the different binaries for the same source code in different operating systems. And it will upload all of them, and they will be managed together in Artifactory. You will get all of them in a coherent way. So for that, it's very useful. I will show you the Jenkins Artifactory plugin. I'm going to show you. So I'm going to try to run a small example here. So here, this will be like a pipeline, okay, in Groovy, for creating a package from sources. So in this case, I'm defining some variables. In this case, is my Artifactory instance. Okay, I'm defining the source code of the package that I'm going to build. Then I will enter my stages. The first one will be to get the source code of the package. I will get a reference to my Artifactory instance. Then this line here, the test package, is actually doing like the heavy thing, is creating the package, building from sources, and testing it to check that everything is correct. And finally, the upload stage is going to take my package with the binaries and upload them to Artifactory. So I'm going to try it live. I'm going to my Jenkins instance, creating a new item. I'm going to call it like package build. It is going to be a pipeline. Pipelines are indeed amazing. And I'm just going to paste this pipeline here. Let's save it. And now I can fire it. So it got the recipe. It configured everything. So the recipe right now is actually hosted in GitHub. So the code I'm showing you is in GitHub, and I will share with you also a link later, so you can check it. Now it is building from sources in my machine. This package is a very simple package. It's just a hello world package with a hello function. It's very simple C++, so it only takes a while until the project is configured and built. Yeah, just let's see what it's doing. So here is just I'm in Windows. This is a Windows machine, and I'm using Visual Studio 14 as my default. So here we can see like the Visual Studio building logs. Okay, so it seems that everything is going fine. Okay, it's finished, and finally it uploaded the packages. So just by firing this, I got here my hello package. Okay, and in this case, I have exactly one binary. I built it just for one configuration. And here I can check the configuration. It's a Windows package for 64 bits, release Visual Studio 14, and with the MD Visual Studio runtime. Okay, now we are having a more interesting example. What happens if those changes are done to a package that is the A package, the library A version 1? So if I'm doing that, I could, for example, bump the version, and I can create like the A2 package. Okay, and that will be fine. The rest of the dependency graph won't be affected. And if I want to integrate those changes downstream, I could just have my developers. Okay, so let's move down. Let's build B2 version of package B, and this B2 version now is dependent on A2. And we could progressively build and test downstream, check everything, and so on. But I'm going to introduce like a more interesting example. Let's think that we have now, we are developing like the head or the develop version. That is, we are continuously overwriting the binaries because we want just to be the latest status of my project. And now some developer is changing something in A. Okay, and now we know how to build A, but what happens with the rest of the project, with the rest of the dependency graph? The thing is that C and C++ is a different beast to other programming languages, because it's not enough to relink B, D, and F. You actually have to fully recompile them because of the headers issues. If you have headers, those headers can be directly embedded into the native code that is generated downstream. Even if they are not headers, linkers can be very aggressive optimizing away, and can do like crazy things. So you will get no traces of those separation between packages when you are building the final native code. Okay, so if you are changing A, you are actually overwriting the latest version of A. You actually have to rebuild. In this case, we can check that we have to rebuild B, F, D, G, and P. Let's call it P, the final project. Okay, and we have to do it. Of course, in this case, C, it doesn't have to be rebuilt because it doesn't depend on A. Okay, so like a workflow for this could be, okay, we are using Jenkins. We are creating like a multi-build. It would be like the orchestrator or the manager of the build. And this multi-build is going to fire like a simple build. The simple build will be basically the build that I've just showed you. It's just taking a package and building that package. So the first step would be, okay, we are going to build A. A will be rebuilt. and the final binaries will be uploaded to Artifactory. So in the next step, when the manager spawns a new simple build task, it will start to build B, and B will depend on A. And when it starts to build B, it will retrieve the latest binary artifacts for A. So everything will be consistent. And then, when it finished building B, it can go and fire F, okay? And at this step, you can say, hey, why not F and D? And I will show you. So it can start working on F, and in the next step, it can fire both of them in parallel, okay? And you can say, hey, why didn't you fire in parallel first D and F? Actually, you can do it. So in this step here, I could have fired the build of F and D packages in parallel. So just the thing that the rationale we are using here is that the longest path from the changes to the final project or product that is consuming is defining the whole dependency tree has the largest likelihood of failing because it has more dependencies. The dependency graph is longer. So then we are trying to build those first. Let's say fail fast. If something is going to fail, we are optimizing the likelihood of failure sooner than in the other way. So in this case, we are building first F, and then we can build D and G in parallel. Actually, this is an oversimplification of this because when you are doing a change to A, it's very likely that you want to build several configurations. So for example, in this case, let's say that we are building 32 bits application and a final 64 bits application. So actually what you have, if you have several dependency graphs in parallel, that they have to be fully revealed, and they can be done in parallel too. So they can be parallelized too. Actually, it's a bit more complicated because those graphs can also intersect. So you can have if B, for example, is a header-only package, you only have to build once for all the configurations. Because header-only packages, they don't change the final artifact for every configuration. So those parallel can join at some times, okay? But no problem, because the tool will be able to manage it. So at the core of what I'm going to show you right now is this command. So there is a command that is called command info build order, that if you provide, hey, I have this project, I'm changing the A package, the library A package, what is the sequence of builds that you have to do to rebuild the project? And it will output a vector or a list of lists what you have to do. So in this case, it's going to tell you that D and G packages, they can be built in parallel because they are in the same list. So I'm going to show you the demo. So here in the repository, I'm going to share with you later. We have like a single build. It's basically this pipeline is basically the same as the one I showed you, just parameters. You can pass arguments to it. So that you can say, hey, I want to build package A, B, or C, or whatever. So I'm going to create a new pipeline. I'm going to call it simple build. It's going to be a pipeline. And I'm going to use this simple task of rebuilding a package from sources. And now I'm going to create a new pipeline. The code for this is a bit more complicated, but basically it's just getting the build order that Conan is telling us, grouping in tasks, and launching a task for each one. So it is like 100 lines of script. Pipeline, okay. Yeah, I just wanted to show you in the repository here, we are also using like two profiles. So what I'm going to launch here will be done for building in Visual Studio for 32 bits and 64 bits configurations. So now I'm in the multi-build, so I can launch my build. Okay, so it initialized, and then it is starting to launch the simple build packages, the simple build packaging. So it's firing depths. So the interesting things here are being executed in the simple build. So let's wait a little bit. So now we can see that it fired 2 builds in parallel. I have configured up to 4 workers in my machine. So one is being used for the multi-build. So it has at most 3 available workers for building. So now it launched just 2 for A, both for 32 bits and 64 bits architectures. So it's computing like both dependency graphs in parallel. Now it's launching B. Okay, even if there is a free worker, it's not being used because until we build B, you cannot proceed down the dependency graph. So now B has finished. Yeah, and now we are getting, it should be F. So we are building in parallel both F library for 32 bits and 64 bits packages. If you remember this, we are exactly here, okay? But building both configuration for F, 32 and 64 binaries. So the next step should be launch D and G in parallel. So let's go here. Oh. Something broke in F, I don't know. Oh no, it seems it recovered. So now you can see it is launching D and G in parallel. So 3 of them are being processed right now. And the 4th one has to wait because I only have 3 available workers. But it launched all of them, the 4th of them in parallel. So now it's finishing. And finally, it will rebuild the latest configuration, the 32 bits configuration for library G. Okay, and we are done. By the way, all the artifacts, they were uploaded and updated in Artifactory. So now my packages here, I got in Artifactory, you can see that I have 2 packages. One will be for 32 bits and 64 bits. So for every library, in this case library A, you can see that I have both packages, not only one. So this. Okay, so my conclusions is that for the first time we have Jenkins, Conan, Artifactory. They are very big enablers for DevOps for C and C++. An explanation, you will get links to the repository we are using, and in the repository you will get the source code for the pipelines. Okay. Also, if you have any question, anything, go to conan.io, and there you have our email, GitHub, because we are open source, so we do lots of supporting GitHub and everything, so you can contact us in GitHub, and please ask anything you want. So that's all from my side. Thanks very much for coming. And if there is any question, I would love to take it. I think. Thank you.